Hello everyone. So we are going to start with the first chapter of your CS1, okay? Which is nothing but probability distribution. Please guys, this is considered to be the one of the most crucial chapters throughout your CS1 journey. Therefore, I would request everyone to do not skip your chapter 1. Chapter 1, probability distribution. You in your 12th standard, you might have studied three distributions: binomial, Poisson, and your normal distribution. But within your chapter 1 of your CS1, you're going to do about 18 distributions. So not only pertaining to your three distribution which is written here, we will be doing n numbers of distributions. These distribution becomes your base for not only your CS1 but even CS2. These distributions are the core of your CS1. So I would request everyone to learn each and every pointers which I give. I'll explain slowly, I'll explain it twice. I do not mind that. You might have to watch the lecture twice, you can do that. But however, I would request everyone to learn each and every line, which indicates right from start of learning your how to identify a distribution, what all are the parameters, and the derivation which we will be doing throughout the lectures. Overall, there would be around 7 to 10 lectures for your chapter 1. It would be around 15 hours of training just for your chapter 1. When I'm investing so much time just for me to teach you, for you to learn, for you to practice would be at least double of the time which I am expecting. So this is going to be a very crucial one. So please listen carefully, even this lecture and go henceforth all the lectures for chapter 1. So listen carefully. What do I mean? What does each distribution indicates, and what all derivation we are doing? Okay. So let's start our wonderful journey with one of the easiest distribution, which is nothing but discrete uniform distribution. Uniform distribution. What does this suggest? How do you identify? X follows a uniform distribution with parameter k. K is nothing but number of possible outcomes. Okay. X is your random variable, and your U, which is written right here, indicates that it's a uniform distribution. Okay, so these are how an indication of a uniform distribution would ideally work. This is very crucial in order to understand what is the possible cases. So probability, the PDF of a uniform distribution is nothing but 1 upon k. Okay, 1 upon k. Now, let me give you an example in order to understand a uniform distribution. Under a uniform distribution, the associated random variable has same probability. What do you mean by same probability? Let's take an example of head or tails. Okay, tossing a coin. If you toss a coin, there are two possible cases: head or tail, which has an equal probability of 1 by 2. Another example: roll a die. There are six possible outcomes: three, four, five, six, each having a constant probability of 1 by 6. See, if you carefully look, k is the number of outcomes. There are how many outcomes? Two outcomes. So probability would be 1 by 2 if you see. 1 by k, 1 by 2. Similarly, rolling a die has six outcomes. So what would be the probability? 1 by 6, 1 by 6, where k is nothing but your outcome. This is nothing but a uniform distribution. Under a uniform distribution, your mean would be equal to your median would be equal to your mode. If I were to draw a graphical representation, we'll just draw a graphical representation in order to understand the concepts better. Let's draw graphical representations of head and tails. Under head and tails, you can see the probability is exactly same of half. So this would be exactly same as your tails one, which is nothing but half. So if you see, what do you mean by a mode? A mode basically indicates the number which has highest frequency. So you can see everyone has the same frequency. The mode also is equal to your mean. Mean is nothing but expectation. So if I were to take this numbers as 1 and 2, expectation would be somewhat here at 1.5. The mean is equal to median, that is the middle point, as well as the mode. Since there is no definite value, therefore mode is 1.5 again. Remember this small details. How do I explain a uniform distribution? What is its PDF? Explain those small things. It would be very crucial throughout your journey. So this was with respect to your uniform distribution. Let's just calculate its mean, okay, as well as its variance. So if you have seen under your initial basic chapter, mean is nothing but also known as expectation of x. What is the formula for expectation of x? Sum of x into p of x. Okay. This is a discrete uniform distribution. This is a discrete case. Okay. Discrete uniform distribution. There would be one continuous as well. But do not get confused. It's going to be a very easy one. So let's just substitute all the values. It would be nothing but x summation of x into 1 by k. PDF is nothing but which is written right here. Perfect. Now, if you see the random variable is x, 1 by k is nothing but a constant. I can keep that out. I'm left with summation of x. Summation of x, sum of all values from 1 to n. So 1 plus 2 plus 3 till all the values till n. So if you have learned your AP in your 11th standard or 10th standard, the formula for AP, the sum of n number of variables, sum of n variables is nothing but n into n plus 1 divided by 2. Okay. So suppose if there were just to differentiate between the random variables, यहाँ पे अगर k होता, sum of k variables, तो क्या हो जाता? This would have been nothing but 1 upon k into k plus 1 upon 2. If I were to simplify this and this gets cancelled, I'm left with k plus 1 upon 2. This is nothing but your formula for a mean of your uniform distribution. Guys, there is also one tables book which has been attached and given to you. Would be under the book section. The tables book somewhat looks like this. So if you see under this tables book, you can find that all the things which I'm just stating out, ki learn this, is already mentioned here. If you see a uniform distribution, everything would be rightfully mentioned here. See, binomial distribution, what would be its PDF, what would be its mean, what would be its variance, everything would be mentioned to you. But however, I'm requesting everyone to learn these things. Why learn these things? There are two reasons. Okay. One, it will improve your concepts and help you to grasp CS1 better. That is one reason. Second reason is while solving sums, you find across some of the distribution which is like not used maximum number of times. So if you see the solution, you would be like quite confused and you would not know what to do. If you have learned those distribution, your mean, your proof, it will not only help you to click better, but it would increase your passing probability as well. So therefore, please follow my instructions to learn each and every step. Everything. You should be so familiar with these concepts that Even if you sleep, you could literally visualize what you have written it in your notebook and what is its formula. It should be so thorough. Spend the most of your time for chapter one only. Don't worry, I'll give you almost 100 sums to practice. But in order to master those 100 sums, in order to be perfect with your concepts, you need to spend more time learning things. Okay? So that's why I'm really focusing on those aspects. Please follow it. This is with respect to your mean. Okay? Now we will derive your variance. What is the formula for variance? Variance is nothing but expectation of x square minus expectation of x the whole square. Expectation of x the whole square is nothing but mean. So mean का तो अपने को आ गया. What we do not know expectation of x square. So let us derive expectation of x square. X square again similar to what we have been doing it in the past. X square is summation of x square into p of x. What is p of x? Again, probability is nothing but 1 by k. I'll just write this as summation of x square 1 by k. Sum from I equal to 1 to k. K is not a random variable. I can keep this out. So I'm left with summation of I equal to 1 to k xi square. Okay. Or you can write any random variable. So this would be nothing but 1 square plus 2 square plus 3 square dot till k square. What was the formula for a AP? What is the formula for sum of square numbers? The formula is nothing but 1 square plus 2 square dot till n square is nothing but n into n plus 1 into 2n plus 1 the whole upon 6. You have to learn these formulas, okay? These formulas also you have to learn it if you do not know. So this would be simply 1 upon k. Instead of n, there are k sum of k values. So this would be k into k plus 1, 2k plus 1, the whole upon 6. Let's simplify. K and k cancel. I'm left with your expectation of x square as k plus 1 multiplied by 2k plus 1, the whole upon 6. Now we'll just substitute expectation of x square and expectation of x the whole square in the equation. So your variance would come out to be expectation of x square minus expectation of x the whole square. What is expectation of x square? K plus 1 multiplied by 2k plus 1 the whole upon 6 minus expectation of x क्या था? K plus 1 upon 2. So k plus 1 upon 2 the whole square. Let's just simplify this. It would be nothing but k plus 1 multiplied by 2k plus 1 minus a plus b the whole square क्या होता है? K square plus 2k plus 1 square the whole upon 4. Let's simplify this bracket also. I'll multiply k with both terms first, followed by 1 with both terms. So first multiplying k into 2k is 2k square, k into 1 is k, 1 into 2k is 2k, 1 plus 1 is 1, minus k square plus 2k plus 1 the whole upon 4, the whole upon 6. Let's common the denominator now. Okay, that is nothing but LCM leke I'll multiply this by 4, multiply this by 6. So I'll be left with 4 multiplied by 2k square plus 3k plus 1 minus 6 of k square plus 2k plus 1 the whole upon 6 into 4 is 24. Let's simplify this further. So 4 into 2k is 8k square plus 4 into 3 is 12k plus 4 minus 6k square minus 12k. minus 6 upon 24. Let's do addition. 8k square, 8k square minus 6k square. Okay, will come out to be 2k square plus 12k minus 12k cancels out. Then plus 4 minus 6 will become minus 2 the whole upon 24. Let's simplify further. 2 कॉमन ले लेता हूँ, k square minus 1 upon 24. 2 and 24 becomes 12. You're left with k square minus 1 upon 12 is nothing but your variance of a uniform distribution. Okay, this is all. This is all for uniform distribution. Don't worry. We'll do some going forward whenever more distribution comes into picture. But I'll give you again. I'll give you the whole summary again. First distribution we are starting with is nothing but a uniform distribution. A uniform distribution is denoted with one parameter that is nothing but k. Okay, that is nothing but k, as you can see here. What is its PDF? PDF is 1 upon k, where k is nothing but number of possible outcomes. I just gave two examples. Tossing a coin, two possible outcomes, so 1 upon 2, 1 upon 2. Rolling a die, six possible outcomes, so 1 upon 6, 1 upon 6. Therefore, everyone has a common frequency or your probability. Therefore, there is no mode. Median and mean would be between those two values. So let's calculate statistically how to calculate mean. So by inputting your formula of expectation of x, which is x into p of x, and then substituting probability value, once we simplify, we'll get mean as k plus 1 upon 2. Variance, expectation of x square minus expectation of x the whole square. Expectation of x square अगर मैं simplify करने बैठूं, it will become k plus 1 into 2k plus 1 upon 6, and further I have substituted expectation of x square and expectation of x into your mean variance formula, and we found the variance as k square minus 1 upon 12. Guys, this is a brief about a uniform distribution, but I would really request everyone to again learn each and every pointers. It would be very, very helpful. Once you start solving some, you'll get a hang over it. Just right now, learn the distributions, okay? What does each distribution suggest? Mean, variance, derivation, and formula learn kar lo. I'm just requesting, or else you will be facing a lot of trouble in CS1. I'm really warning you guys, okay? So yeah, with this, let's end the first lecture. I'll keep it simple. From second lecture, we'll go on to build our base through other distributions. Again, similarly with other distribution first, we will find how to denote that distribution, what all are the parameters, and then mean, variance, and the derivation we'll do it respectively. So that's it from the first lecture. If you have any doubts, you're free to reach me. I'm Viraj Shah from the Actuarial Academy. Hope you have a great day ahead. Thank you guys. Bye bye.